Hello and welcome. In this video, we're going to take a look at quadratic functions. Now, a quadratic function is a polynomial, which means that it's all algebraic operations. You're going to have powers of x, if that's your variable, and the highest power of x is going to be x squared. So that leaves you with the possibility of three terms. You will have an x squared term, you may have an x term, and you may have a term that just involves a constant. Three terms makes that a trinomial. So we're going to take a look at the sort of standard form for what a quadratic function is and take a look at its graph. So let's take a look at the notes here, and I've got you listed here as sort of the basic fundamental form of a quadratic equation or a quadratic function. And that's when you have any sort of function of the form f of x equals ax squared plus bx plus c, a, b, and c all being constants. And it's probably good to just note you can't have a equal to 0, otherwise we'll be back to a linear function. And when you try to graph this quadratic function, the shape that we get as a result is called a parabola. Okay, now if you're not familiar with what a parabola is, here's a couple examples of what a parabola might look like. And so you may want to just sketch a y-axis, an x-axis. And a parabola, of course, is not a linear function, so it's not a line. It actually involves more of a U shape. Now, it should be a nice smooth curve, and it's going to be symmetric, even if mine doesn't look like it. And it can open up or it can open downward. So as you can see, it's the same shape, but it can open upwards or open downwards. And what really the most important part to look at to understand whether it's going to open up or down is you need to look at a. It's the leading term, the one with the highest power, and a being the leading coefficient, the number in front of the x squared. So in the first case, if a is positive, then our parabola, we say, opens upward. And in the second case, if a is negative, then our parabola opens downward. Now, in both cases, you end up with a single point being the highest or lowest point on the parabola, and that point is called the vertex. A parabola can only have one vertex. It only has one maximum and one minimum value. So it's definitely of great importance where you know that point is, and that point also helps you to form the axis of symmetry, so it's a mirror image on both sides of that. It's, definitely one of the most important things to know. Now, there is a shortcut for finding the vertex, and this is going to be a lot easier to explain this shortcut once we actually dive into more of the calculus side of things. With calculus, we're going to be looking for maximums and minimums of all kinds of shapes. And parabolas, quadratic functions, are going to seem like a pretty easy case once we get through that material. So, spoiler alert, this is going to be revealed later why this works, but the vertex can always be found with the formula x equals negative b over 2a. If you know what the x coordinate is, just by plugging the values of b and a into that little shortcut, then you can find the y coordinate by plugging that value of x back into the function. The y coordinate is going to equal f of negative b over 2a. Now you know how to find the vertex. You can find its x and y coordinates. But there's some other points on this parabola that are also going to be of great use to us. And those are going to be the points maybe where it crosses the x and y axes. Those are called the x and y intercepts. Now, the easiest of those to find is actually the y-intercept, because all you need to do is plug in x equals 0. Because it's a function of x, it's easy to plug in values for x. So the y-intercept is f of 0. Now, because the function is ax squared plus bx plus c, if you plug in f of 0, then you should just get c. So that is your y-intercept, and it's a pretty easy calculation. However, the x-coordinate, the x-intercepts are a little bit trickier to find because, as you can see in those pictures above, in these graphs, our graph crosses the x-axis twice. Now, there are a few different scenarios that we can have depending on where the parabola, where the graph of the parabola lies in the xy plane. So there are sort of three circumstances that we might have. Option number one is we have a parabola whose opening up and is significantly above the x-axis, or opening downward and is significantly below the x-axis. And as you can see from that graph, it doesn't even cross the x-axis. In our second scenario, maybe we have a parabola opening up or down, and its vertex is actually on the x-axis, and that would be a single point. If we happen to have a scenario like above, though, then we've seen that we can actually have a parabola cross the x-axis twice, leaving us with two x-intercepts. So the three options for x-intercepts, we may have 0, 1, or 2 x-intercepts. Now suppose we wish to find those x-intercepts. The only thing that all of the x-intercepts have in common is that they have a y-coordinate of 0. Now remember that the output, f of x, is giving us the y-coordinate, so we're going to replace the f of x piece of the function notation with a 0 and then solve for x. So to find the y-intercept, we're going to have to set f of x equal to 0 and solve for x. That leaves you with ax squared plus bx plus c equal to 0. And the moment that you've taken a quadratic function and you've made it equal to something, now you're left with what we call a quadratic equation. Okay, wow. Now we have to solve a quadratic equation. It's not as easy as a linear equation. With linear equations, it's easy to add and subtract from both sides, multiply in both sides by a non-zero constant until we can get x by itself. But here we have an x squared and we have an x, making it a lot more tricky just to isolate x. So there are a couple different options of methods to solve a quadratic equation. I'll show you both, although I suspect you may be choosing the quicker option. Why don't we take a look at a quadratic equation with a few of the values filled in. So 2x squared minus 5x plus 2. Right off the bat here, you can see I have written it in descending powers, which is the best way to write a quadratic equation. If you don't write it that way, you may end up confusing yourself with one of these methods. So it's much better to make sure that you have a first attached to the x squared term, b, which includes the negative in the negative 5, next to the x term, and then you have c, which is going to be a constant and it doesn't have any x's. So now you can label those a, b, and c. First option that we have is factoring, and this is great anytime you have multiple things equal to 0. If you have a factor times another factor, and maybe you have a third factor or more, anytime you have a product equal to 0, this is called a zero product. Not exactly a creative term. But anytime you have multiple things multiplied to equal 0, one of the properties of real numbers is that one of the factors must be equal to 0. You can't multiply a whole bunch of non-zero values but have the product equal to 0. The only way that happens with real numbers is for one of the factors to equal 0. So then what you can do if you ever have multiple things equal 0 is you look at the first factor. Maybe this is factor number 1. And you set that equal to 0 and you see what you get for an x. And then you take your second factor, call this factor number 2, and we're going to set that equal to 0. And then you might be able to solve that. And typically if you take quadratic, you can try factoring that and you'll end up with linear factors. And each of these smaller factors, when you set it equal to 0, is a linear equation, which is much easier to solve. So with that idea in mind, the first strategy here, strategy number 1, is factoring. Now with factoring, you may have learned to just try guessing a few values, popping them into some brackets and expand it out and check. The guess and check method works for simple quadratics, but I'm going to show you guys the AC method for factoring a quadratic such as this, which is a little bit trickier. Now there is a little theory behind this. You understand why this method works. When we try to factor this, the idea, and I'll put it off to the side here, is we want something to look more like ax plus b times cx plus d. Those are both linear factors. They both look like a mx plus b kind of idea, so they're going to be a lot easier to solve individually. Now, using the distributive property, if you want to expand this whole thing out, ax times cx will give you acx squared. Ax times d is going to give you adx. Multiplying the inside terms, bcx. Multiplying the last two terms, bd. Now you'll notice that the two middle terms can combine together. acx squared plus a single term here with an x, ad plus bc all times x plus bd. And you can see that when you have ax plus b times cx plus d and you expand and collect, it becomes three terms. What we're trying to do by taking our equation, 2x squared minus 5x plus 2, and factoring it, is we want to reverse that process. And so the first step in what we call the AC method is to take the three terms that we have and actually try to take that middle term, split it into two terms, and then we have four terms, and factor those into the two sets of brackets. So we're just reversing the process of what I just showed you in green. All right, called the AC method. And it's called the AC method because what we do is we look at the values of A and C and we multiply them together. AC in our case is going to be 2 times 2, and that equals 4. Okay, now there is still going to be a little bit of guessing and checking, but less than you would have to do if you were trying to guess a whole bunch of numbers, the four numbers that need to go into both sets of brackets. So what we do is we look for a way to split up that middle term. So the middle term is negative 5x. We need to split something up so that we have two new terms that add together to equal negative 5. Two numbers that combine together to give you the middle term. Now the AC component, we need to have two numbers that multiply together to equal 4, which is AC. And it makes it easier to guess and check because you just need to go and try to find values that multiply to 4. There aren't that many of them. Now, to get to things that multiply to 4, they either are both positive or they're both negative. You can't have one of each because we have the product equal to positive 4. So you might try 2 and 2, but you can also try 1 and 4. And if you have a negative 1 and a negative 4, they add to negative 5. That means we found our two values. So in this AC method, the first step is looking for the value of AC and finding numbers that multiply it and add to the middle term. And then what we do is we take the middle term and we split it up into two terms. So just kind of like reversing the process of what I just showed you in green there. This is the final product, and we're going kind of backwards, the factored form. The next step is actually splitting up the middle term. Instead of minus 5x, and use minus 1x minus 4x plus 2 equals 0. Okay, now how do we take that and factor it into two sets of linear factors? We do something called grouping, and we group the first two terms and we group the last two terms and look for a common factor of 2x squared and 1x. The coefficients 2 and negative 1 don't have much in common, so the best thing you can do is factor out a 1. You could factor out a minus 1 if you chose, but let's just factor out a 1. And we can also look at the powers of x. We have an x squared and an x. That means we can factor an x out, and that leaves us with two terms. 2x squared, when you factor out 1x, leaves you with 2x. And negative 1x, when you factor out 1x, leaves you with negative 1. Now, negative 4x and positive 2, the 4 and the 2 do have a 2 in common, so we can factor out a 2. And we can factor out a negative 2 if we choose. The good news is if we factor out a negative 2, then we end up with a positive 2x and a negative 1, which is the same linear factor that we just got when we looked at the first group. And because they both have a common linear factor, 2x minus 1, then we can factor 2x minus 1 out of the two groups. Factoring the 2x minus 1 out leaves us with 1x from the first group, and it leaves us with a minus 2 from the second group. And there you have it. We've actually got this thing factored into x minus 2 and 2x minus 1. Now that you've got it factored, we haven't actually come up with a solution yet. Now you can use the idea of the zero product. X minus 2 might be 0, and that would give you a product of 0. Or 2x minus 1 might be equal to 0, and that also would give you a product of 0. We look at each of these two factors individually, and we say, well, one option is that x minus 2 equals 0, and the other option, 2x minus 1 equals 0. Both of these being linear equations mean I can just add a number and possibly divide. Add 2 to the other side, x could equal 2. That's one solution, and that's one of our x-intercepts. The other option, 2x could equal 1, in which case x must equal a half. And so that is our second x-intercept. The x-intercepts of this parabola would be 2, 0 and 0.5, 0. Because remember that x-intercepts always have a y-coordinate of 0. Okay, now factoring using the AC method, not for something I liked doing. This can be a lot easier if a is equal to 1, in which case then you might just be able to guess the two values, x plus something or x minus something in each of the brackets. But let me show you another method that you're probably going to be using most of the time to try to avoid this idea of factoring. I want to show you this factoring method because in a lot of examples that we tend to use during class, a lot of the values work out to be nice whole numbers, and that's because you can factor them. Factoring, however, can be a really tedious process, and it doesn't always result in nice factors. So, if you haven't already thought about the other method, here it is, and it's called the quadratic formula, and it's everybody's favorite friend, and a lot of calculators will do this automatically for you. So keep in mind, this is probably what I'm expecting you guys to be doing in class most of the time. Okay, the quadratic formula is for quadratic equations of the form ax squared plus bx plus c. So make sure that you've got your equation in that exact format before you start trying to apply this formula. To solve that equation, you can just as easily say, well, x is going to end up being equal to one of two values, and that's by taking negated b and then adding or subtracting the square root of b squared minus 4ac. That already gives you two different values depending on if you add or subtract, and then take that result divided by 2a. Now, I'll highlight this piece inside the square root, b squared minus 4ac. If you end up with that number being negative, then you won't have a real solution. And that would be in the case where you end up with a parabola that doesn't cross the x-axis. Now this number is called a discriminant. So a negative discriminant means no real solutions. If that discriminant equals 0, then you're adding and subtracting 0, which doesn't give you two values, and that's how you have a parabola that's just touching the x-axis at its vertex. So this thing here is known as the discriminant. With this lovely formula, or with a calculator that can do this automatically for you, it's just a matter of inputting a, b, and c into that formula and churning out the result. Going back to our example, now because I have b being negative 5, this is going to be negative 5, that makes it a positive 5. And be careful in the square root, if b is negative, when you square it, squaring a negative makes that positive. And so there you go. You can end up with two results depending on whether you add or subtract And you should end up with exactly the same two values for x equals 2 or x equals 0.5. Don't forget that those are simply the x-coordinates of the x-intercepts. The x-intercepts themselves will always have a y-coordinate of 0. So that's probably going to be the way that I suspect most people are going to use a method for solving quadratic equations. Certainly is a lot easier when you get your calculator to do it for you automatically. Probably a good idea if you haven't picked one up, get yourself a decent scientific calculator that has that ability already built into it. However, just keep in mind, the reason why I showed you factoring is actually because a lot of times I like to use examples that have nice results, and that means that typically you can factor them and you don't have to worry about getting approximations of the correct answer if you've rounded something incorrectly in your quadratic formula. All right, well, hopefully that gives you a little bit of knowledge about quadratic equations, quadratic functions, parabolas, vertices, lots of stuff in there that'll come up frequently. And like I say, there's a couple things in there that, like the vertex, once we get through calculus, that negative b over 2a is going to make a lot more sense. So a little spoiler alert for later. That's it for now. I'll see you guys in the next video.